Hello, everybody. Welcome to the Java and Google Cloud Platform Talk. My name is Patrick Flynn. I'm the tech lead for the Java tools team on Google Cloud Platform. So, all your tooling needs for build tools, Maven, Gradle, IntelliJ Eclipse, that's us. Oh, wait, I also forgot that, I've been working at Google for around 9 years now. I've only been on tools for the last 2. Before that, I worked in ads, Java server infrastructure. And before that, I sort of suffered in the wilderness working on supply chain management, Java backends.
Okay, hey everyone, I'm Rajeev Dayal. I'm an engineering manager here at Google, and I manage the Java tools and the Java runtimes of the Cloud SDK teams. I used to be the tech lead of the Google Web Toolkit, or GWT, as it is now called, and the Google plugin for Eclipse. And before that, I used to work on, at a company called Autotrader.com, was doing web front-end work, actually, and dealing with the joy of Ajax.
Here's some stuff you may not know about the Google Cloud Platform. So really this talk today is going to be focused on a demo around how to deploy Java to Google Container Engine, and then how you should debug a scaled service across multiple instances. But we thought we'd kind of like go through memory lane, explain to you how we got here. You probably know some of this, but the Google journey is kind of different because Google is, in some way, was very isolated from the external community. I think so. The first Google server. I don't know if any of you guys know. Does anybody know what the first Google server was made out of? Anyone? Parts of it were.
That is partly true.
That is partially correct. You get partial credit for that answer. The rest was made out of Legos. Oh,
Whoops.
Dude.
Yeah.
Okay, so that's a really cool server. I've built a lot of servers. I've never built a Lego server. And that is really the first Google server, but it was at Stanford before they were actually serving like commercial traffic.
And Google has a general love of Legos. There's just Legos all over the offices. This is probably why. So,
yeah. We iterated on the Legos server, and eventually Google kind of became a commercial company, but it was always known as a scrappy company, well, at least internally. The motto was always try to do more with less. And we were kind of notorious with the data center space that we rented for kind of cramming in as much equipment as possible. So like the next server was actually built in part with corkboard. So that was an actual Google server rack. We didn't even have cases for the computers. They figured out they could put more into this space by not having cases and just separating them with corkboard. I don't think it's very safe.
Yeah, it seems like a fire hazard.
Yeah.
Yeah.
I wouldn't recommend.
I think it was a fire hazard.
I wouldn't recommend this strategy anymore.
Yeah.
I guess it worked for a while.
Yeah.
In any case, we've iterated on that design. And today, we have less scrappy data centers, I would say. Right? And I didn't mean crappy, I said scrappy.
Yes. Yes, it's a big difference.
We design and build and own our own data centers. Everything that we offer is provided on premises that we control.
We have a tiled floor now. All the wires are nicely hidden. So it's a vast improvement over the corkboard story. Yeah.
And actually, this is a picture of one of the latest data centers. I'm pretty sure it was the one that was built up in Scandinavia. I think it's kind of beautiful. It looks like a computer chip, but blown up like by 1 million or something like that.
Yeah.
One of the cool things about these data centers is that they are actually like pretty much carbon neutral. They don't use carbon electricity. They use hydro, I think.
Yes, that was I think it was a couple of years ago we achieved that. But yeah, that was a really big accomplishment, actually, to be carbon neutral for data centers. Yeah.
But since yesterday, we don't really care about that.
Yeah. We're going pure coal for our data
The
centers.
next data
Announcing
center is
today,
going to be
pure coal. Yeah.
You heard it here first.
Yeah. Coal power.
Coal powered.
I like it. All right, so moving on from coal, given that you have a data center, what do you do with this data center, right? You have a lot of computers, a lot of things happening. How do you actually run software effectively in a data center, right? And this is where Borg comes into play, actually. And this beautiful picture of Borg Borg Cube was drawn by Patrick.
Wait, yeah. Rajeev, before you worked at Google, how did you manage all your jobs on your back ends?
Well, let's see. I mean, it was a lot of bash scripts, effectively, right? Bash scripts, grepping logs, and copying them to random places.
Would you set up the
mounts.
servers yourself?
Yeah,
all that stuff.
Yeah, exactly.
That was tedious.
It was extremely tedious, actually. Yeah. So with Borg, and what Borg is really it's a way to run internally, a way to orchestrate containers across a bunch of physical machines. Now, the idea of running compute workloads across a cluster of computers is not new to Google. I mean, that was its initial claim to fame with search. It was really running pretty much really good software on very mediocre hardware, right? Things have evolved since then, and now what we've got is we have this system called Borg, and it allows us to basically orchestrate container workloads internally. So using containers, though it's come in vogue in the past 3 years for good reason, Google's been doing it for many years, actually. Internally, we've been doing it for many, many years. And actually, Google engineers contributed to C groups and pushed that into the Linux kernel, which is sort of the basis of containerization on Linux.
I'd also like to point out that a Google engineer drew that picture of the Borg cube.
Yeah, that was you. That was you.
That was me.
That should be the new logo. Yeah.
We have lawyers and stuff, so we have to be kind of careful what we put into slides.
Yeah, I mean Paramount really owns the Borg cube, right? Star Trek. So, are
we ready for the next slide?
Yeah. So, I mean, the only other thing I'd say about Borg is just relating this to Kubernetes, right? Kubernetes, which I mean is talked about quite a bit, is really, you can think of it as almost like the externalization of Borg. In fact, many of the Borg engineers actually were contributors to Kubernetes, and it's not quite Borg v2, but it's actually an improved version of Borg that's just open source, right, to orchestrate containers in a similar fashion. And we probably let the cat out of the bag here, but what do we run? What do we run actually on on Borg? What do we do on these data centers? Right?
I don't know. What do we run?
Why don't we flick over there and see? Okay, Java beans or Java. We run a lot of Java.
We do. We run a lot.
We run Java. Java we've been running for a while, and in fact, we actually run a heck of a lot of Java. A lot. It's a lot of beans. There's actually a prize if you can tell us how many beans are in this picture at the end of the talk.
Or if you told us how many lines of code
that's a more interesting
question. In the Google source repo that are Java.
Any guesses?
Let's throw a number out there.
More than 100,000? Anyone?
1 billion.
No, we're lower than that. I wish we could say yes, I think. But no, we're lower than that.
We have more lines of code than that, but not of Java code. I think this is the first time we've ever released this to the public, but we have around 230 million lines of Java code in one Google source repo.
Yeah, so we're, that's a lot of Java code. And, Google as a company has been deeply invested in Java. It's actually one of the 4 major languages that we use at Google. And, a bunch of the work you all have actually seen externally. So Guava, GWT, Juice, Dagger, Bazel is the open source version of our build system, which is actually written in Java. So there's a lot of work that we've actually done on Java over the years. And what we're trying to do, what we've been doing in the past couple of years is actually taking the experience and expertise we have with Java as a company and actually focusing it on the Google Cloud Platform. How do we bring this knowledge and expertise to the external world to make it easy to build, develop, and run workloads on Google's Cloud Platform, Java workloads on Google's Cloud Platform? So, just to say, okay, so how do you run a Java workload on Google's Cloud Platform? I mean, many folks may not actually know that, right? And there's a few services that we offer to do this. So there's App Engine. Maybe some of you have heard of App Engine. It was released in 2008. and it first supported Python. Java, I believe, was released in 2009. And this was the birth of platform as a service. I mean, there really wasn't the term before then, actually. And it's sort of like, this was kind of our first foray into having cloud computing, right? So that you could give us code and we would run it. This was the first thing we actually did. And App Engine's interesting because you just think about the code, right? You don't worry about machines. You don't worry about the network, the operating system. You don't worry about scaling, actually. You just give us the code and we run it and we scale it, right? And the types of apps and services you can actually run on here are, Java servlets, right? Just typical Java, old-style Java web app. And actually, in the beta, we're actually putting out App Engine Flexible Environment, which is in beta right now. And you can actually run containerized workloads on App Engine as well.
Yeah, one thing that we should probably mention is, I mean, you've probably all heard of App Engine, but what's not well known is that there are a lot of very successful companies that have scaled enormously with App Engine, right? I think one example is Snapchat, which is now a really very, very, very high traffic app, and they are running on Java App Engine Standard.
Yeah, they basically grew up on App Engine, and they're still on App Engine. So another service that you can actually run on is called Container Engine, actually Kubernetes, but then hosted Kubernetes. Google hosted Kubernetes is known as Container Engine. And here you obviously think in terms of like a container, right? So you don't really worry about the machines and whatnot. You don't really worry much about the network setup. You worry about the OS and your dependencies there, but you think in terms of the container. And you can kind of run anything, right? Any Java app or service can be containerized, can be run there. And then finally, I mean, another sort of a more fundamental piece here is compute engine. And here you're getting a virtual machine, right? And you can get a virtual machine. You can actually select from a bunch of different OS images like Debian, Ubuntu, SUSE, all of those, Red Hat. You can actually you can even get a Windows machine if you want to. You can custom size it. So there's a feature that we have, so you can actually pick the exact number of cores you want for your workload. And you can install what you want on it. And this is obviously very flexible, right? You can just do what you want. It's a machine.
The custom sizing, I think, is unique in the industry. Typically you have to pick, if you need 8 cores, you're going to get 42 gigs of RAM with it or something like that. Yeah. And you're going to have to pay with that RAM, even if you don't need it. On Google Cloud Platform, you can actually customize exactly how much RAM and how many cores you need and only pay for that.
Yes, exactly. So yeah, these are kind of how you would run workloads on GCP. And one thing I'd point out just on this slide, I didn't really draw it, but just going from the top to the bottom here, you're really going down this sort of what we call the compute continuum, right? From platform as a service to container as a service to infrastructure as a service. And the higher up you go, it's sort of the less you have to worry about, less you have to do, but you have less flexibility. The lower down you go, you have more flexibility, but you need to manage more yourself, right? And you want to give the ability for people to operate at all levels of this continuum, because it really depends on what you're trying to do. All right, so yeah, it was a bit of stalling. What do we actually do, right? What do we actually do here? So, what we're doing on Java for Google's Cloud Platform is probably divided into 3 categories, right? There's tools, there's libraries, and there's runtimes. So on the tooling front, we're building support into Eclipse and IntelliJ for basically initially working with App Engine, right? So that's getting started, locally running and debugging, and deployment to App Engine. Right? We're also doing work, or have done work, to debug live production workloads. And that's actually some of the work that Patrick's going to show you soon. We're also doing build tool plugins for Maven and Gradle. And these are helping you package and deploy your application to App Engine. This is where we've been spending our efforts now. And as we move on, we're going to move on to more of the features around Kubernetes in the future, in the coming year. Another important area is actually building idiomatic client libraries if you want to use Google Cloud APIs. So all these APIs here, like storage, data store, BigQuery, PubSub, these are all, they're REST APIs. So you can always hit it with HTTP, right? But that's kind of ugly if you're trying to write a Java application, right, to use these things. So previously, for some of these services, we auto-generated a bunch of Java code, right, so that you could call these APIs, but it was kind of ugly. It was not idiomatic. It would work. It was in Java, but it was pretty ugly. So we put a lot of time and effort into building idiomatic Java client libraries to use these APIs. And actually, an interesting thing is there's support for these APIs using gRPC. gRPC is, if for those that don't know, is the open sourcing of one of our internal our RPC protocols. Actually, so we open sourced it, and it's highly performant. It actually relies on HTTP2, so you actually get a lot of benefits, performance benefits, by using gRPC. And the third area that we're working in is basically the runtimes area. So what are these? The runtimes are base Docker images for Java workloads that we actively support and maintain. So we have an image for the OpenJDK, the OpenJDK plus Jetty9, and what we do is we maintain them, we patch them, we make sure they're performant, and we actually make sure that if you're running a workload on them, you get a bunch of the diagnostic features of Google's cloud platform out of the box. One of them is called the Cloud Debugger, which Patrick is going to go into soon. And we actually are working as well, or we will start working on a runtime for Tomcat. Oh, and yeah, one last thing I'd mention, it's all open source, and we have links at the end of the presentation, so you can go check it out. All right, but putting this back to Patrick, like how can all these tools and all the work we're doing actually help you as a developer?
So how many of you in the audience are Java backend developers? That's a lot of you. What a surprise. How many of you have ever experienced a bug in your servers that you could not reproduce locally? That's a pretty common scenario. It's kind of like you lose your hair over that kind of thing, right? And,
yes.
Rajeev, has that ever happened to you that, before you worked at Google, you had kind of a head scratcher that you couldn't fix, and then you had to go through some kind of painful ordeal to do it?
Yes, yes, many a time. At one company I worked at in particular, it was we had a web front end in Java, and it got decently high traffic. I mean, it was about 16 million hits a day, so not Google scale traffic, but relatively high traffic. And but at this new deployment, and JVMs were just kind of crashing, right? They were just crashing, and it wasn't. It was sort of unclear why. It was a memory problem. And then we realized, okay, there was some issue with our caching logic, right? Because we weren't using Apache's JCache or anything like that. We actually had our own caching, which is probably a mistake, but we did. And so we basically had to log and say, well, how full is the cache? What's the hit rate? And then we added these logs, but guess what you have to do? You have to deploy your app again so that you're logging all that information. And then there wasn't magic services to do any aggregation of this, so I had to write some pretty terrible scripts that would SSH into all these machines and grab the logs, and if the log was a gig, then there would be problems, and then I would use grep, and I'm pretty bad at grep, so we would do all these things, right? And then when you dig in a bit more and find out more information, and guess what, you have to add more logging because you just need more details, and then you deploy again. So it was a 2-week ordeal.
The cycle is crazy.
Yeah, it was 2 weeks. It took 2 weeks.
And that was a while back,
yeah.
Right? I had kind of a similar story, but we used Windows, and that kind of made it 10 times slower, 10 times more painful.
Took you 4 weeks.
Yeah, really. Oh, sorry, Windows developers. It's a lot better now, I know.
Yeah.
So one of the cool things about coming into Google, is that you have this incredible infrastructure, right? Hardware infrastructure. You're running at massive scale. But then what happens when you have 100,000 jobs running on that cluster and you start getting some kind of threading related bug that you just cannot reproduce, right? You need some way of getting diagnostics information about what's going on in your Java jobs. So I think that's cut to demo, right?
Yep.
All right.
Let me flip you over. Oh, whoops. There we go.
Okay. So the first thing I'm going to do is create a Kubernetes cluster. So if you look at this command, so Kubernetes is open source. You can run Kubernetes anywhere you like. But Google Cloud Platform has a managed Kubernetes service that we provide for you. gcloud is a CLI for the Google Cloud Platform. So we have a container subcommand which has kind of groups together all the container-related commands. What I'm doing here, I'm calling gcloud containers create deployment. The buggy is the name of the deployment. and then I'm passing, this is actually important for the Cloud Debugger. You don't actually need it otherwise. The Cloud Debugger OAuth scope to give so that the user agent has it to be able to talk to our Cloud Debugging service. Oh, wait. Oh, no. Okay, let me, well, if it's already running, do I start it and restart? Yeah. Got to. Okay, so I'm going to delete this cluster. That takes a little while. So the infrastructure in to run a Kubernetes cluster is kind of significant, right? There's networking and virtual machines. So these commands take a while. They're going to spin up the master, spin up all the nodes that you want, so let me actually just go to the sample code that I'm going to show you. This is a really simple example. I just wanted something that people could grab right away. If you can have a simple threading example that you think of, email it to me. Okay, so what this service actually does is it exposes an endpoint that returns the browser that you're using, right? So if you look through here, we check the user agent. If it contains Mozilla, which is Firefox, open source name for it, we return Firefox. If it's Explorer, we return Explorer, etc. You get the idea. Let's see. Okay, it's going to take a while. Let me go through. So the next thing that's actually super interesting is the Docker file, right? Oops. Let me zoom in a little bit. Okay, how many of you have used Docker before? So you're familiar with Docker files. There's nothing really crazy going on in here. One thing to note is that I'm just using the OpenJDK 8 image. That is not curated by us. It's not managed by us. We've got no code in there, which is why I'm configuring the agent manually in here. Just wanted to show you that you can use whatever you want to use the Cloud Debugger. In fact, you can run the Cloud Debugger off of Google Cloud Platform, but you would have to speak to our Cloud Debugger service through an API. What I'm doing here, I'm going to highlight, there's this run wget. We're downloading the Java debugger agent, exploding it, and then if you look at the entry point down at the bottom, we specify the agent path to where we installed the Cloud Debugger agent. And then also what's pretty important here is, geez, why can't I get to the end?
You got the service name at least.
Yeah.
Yeah.
So the Cloud Debugger runs on as many instances of any kind of service that you want, right? But we don't know if your App Engine, Kubernetes, something else, right? We need a model that we can use to identify the service. So, I mean, there are various ways that you can do this, but in this case, what we're doing is we're passing in the service name and the version of the job that we're running to the agent so that when it reports to the server knows, can identify it so that we can actually set the breakpoints that we want to. Let's see how delete is doing. Okay. All right. So it's going to take a little while.
Actually, I mean, maybe we could talk a little bit about just like the Cloud Debugger, like the Cloud Debugger itself and what it is. I mean, maybe from the name, maybe it's obvious it like debugs things in the cloud, but what it's really like, what the product really is it's what's called like a postmortem debugger. So the idea with if you're like running a workload, the idea is to be able to set basically set like a watch point, right? It's kind of like a breakpoint, but you're not actually breaking execution, right? You're actually just stopping there and it's sampling and taking for any time that is hit, a sample's being taken and that you can actually look at later, right? So that's basically what the service is, and it's useful for production debugging because you don't want to stop execution.
Yeah, it's kind of the miracle that you were looking for when you had that impossible to reproduce bug, because you've got 1,000 instances, right? You don't know where it's going to happen. You can't like connect your debugger, because even if you did know what instance was going to get hit, you would be actually stopping production traffic. The user experience wouldn't be what it should be, right? So let me just kind of show you how we configured this app. I've got a bunch of properties here, like I specified the service name based off the artifact ID, our GCP project ID. And one thing that I did basically as a means of injecting the service inversion into the Docker file is I just used the Maven resources plugin to filter it into our target directory. So I'm sure you're all familiar with that plugin if you use Maven. And then we use the Spotify Docker Maven plugin, which is a Maven plugin that helps you do Docker-related active things like build and publish Docker images. Pretty cool. So what I've done here, like you can see, is that I've added the Docker directory, which is my filtered target directory of the Docker file. I have the target path, and then I include the final jar that I've got. One thing that I did that I thought was convenient is I bound the install phase of Maven to the build from the Spotify Docker goal, because why not, right? You're building a binary and you're putting it into your Maven repo. Might as well build the Docker image and put it into the Docker local Docker repo. Finally, this part is important for I should talk a little bit about source context, right? It's not enough. I mean, it can be useful to just not have source context and run the debugger agent and see the values, but like you kind of want to know what version of your code is running in production so that we can actually tie that to your source. So what we do is we have a goal in our App Engine plugin, which will generate source context files for you, which are just a file format that we created to capture the, for now, I think it's only Git repos.
Yeah, so Git repo and then the commit hash. Yeah,
exactly. And what we do is then we package that into your application when we deploy it. I think the final kind of neat thing that I did is so we have this Docker subcommand of gcloud, which kind of wraps it and provides the context of gcloud credentials and stuff like that. And we also have, I don't know if you know, a Google container registry where you can publish your private containers that you don't want to share with Docker Hub, for instance. And it's obviously performs really well. And what I did is I bound that to the deploy phase of our application. So our clusters come up. It's got 3 nodes. What I'm going to do is I'm just going to where am I? Oops. Okay, I'm going to Maven deploy. So another interesting thing that we do is we do a lot of caching of like container dependencies, and we even have like a Google cache of Maven Central so that you can configure your projects to build really quickly if they're building on the cloud platform. As you see, I pushed and deployed to GCR in 14 seconds. Okay. So after the build, what we're going to do is we are going to run the app. So actually, we're going to, actually, maybe what I'll do first is show you the app running locally so you have an idea of what this application does. Where's the play button? How's this sort? So as you can see, it's just a standard Spring Boot app, right? This is strange. What's going on?
That's Chrome, isn't it?
Yeah. Yeah, something is wrong with our service. How are we going to fix it?
Get an IDE. Let's fix it. Yeah.
All right. Well, first, let's deploy the app we've built it. Let's deploy it to production. What we'll do is kubectl run the deployment name, point it to the image that we just built. It's running on port 8080. And that was that fast. It's kind of amazing how fast Kubernetes brings up services. It's like literally order of seconds by the time that all the containers are up. And then what we have is, so the other thing that we need to do is once it's up, so Kubernetes is not a platform as a service, right? When we bring up jobs in our cluster, we don't necessarily have an endpoint that's public on the internet that people can can go through. So Kubernetes does offer a means of actually doing that. So what I'm going to do is expose the deployment through a load balancer. Okay, that was fast too. So if I, let's see, get service. Yeah, so provisioning the external IP takes a little time, right? But the service is up. So we can actually connect our cloud debugger right now if we want to. Oh, it's kind of small. So what I'm doing here, let me zoom in. There we go. If you see down here, we've got this run configuration. It's a Stackdriver Debugger. What I can do is connect to it. So you can see that I've selected the project Java Tools DevOps. It'll auto-select your latest deployment, which is the service name and the version that we provided. Right? Now we can attach to it. And let me zoom back out. Now I know what happened earlier. Okay, so now we are actually connected. Let's actually see how we're doing provisioning that external IP. We got it. So let's see, this is an older one, so the IP isn't correct. This is the external IP, run it, and it's working. It's running on GCP. And let me actually scale this up. So I'm going to put maybe 3 replicas. So that's now creating 3 replicas of our service, right?
How many was it to start with?
1, I believe.
Okay.
Okay, so that means we now have 3 instances running at the same time. And we want to debug this, right? So what are we going to do? We go into the hello controller. So we know that display name doesn't return Chrome. So that line probably isn't going to get executed. We know it returns Firefox, so we might as well just put this snapshot here. As you can see, there's a little check mark that just confirms that the service has acknowledged that this is a valid breakpoint in the system. And all we have to do over here is just refresh. And you can see, let me zoom in. Oh, it's gone. I hope some of you guys saw that. So basically, if I don't know if you can actually change the font on this part of the UI. But so if you see, I guess it's not too bad, right? Basically, you see the stack, right? If we go back, oh, what happened here?
I think you zoomed in a lot.
Oh, really?
I think, yeah, the zoom.
Oh, yeah.
Yeah.
Okay. Okay, so you can see that we returned. We're done, right? Nothing blocked. But it looks like I hit a breakpoint, right? And I can see the state was Michelle. I can go and dig into the request, see the user agent. Hold on, the user agent is Mozilla. That doesn't make any sense.
It's Chrome's lying.
Why does it do that?
I think they all say Mozilla.
Yeah. Yeah. So yeah, if you deal with browsers, you know about this stuff, right? So, I mean, that's pretty cool, right? It's fantastic. But typically, if this is a really hard to reproduce bug, right, your workflow isn't going to be like, I'm going to kick up my legs and wait until somebody actually triggers this bug, right?
Yeah, if it's over like a bunch of machines and it doesn't happen all the time, yeah, who knows how long you'll wait.
Exactly. So what I'm going to do here is, so another thing to know is that these snapshots, they're called snapshots once they're collected, we certainly don't want to capture all the snapshots, right, when that code gets triggered. So what we do is we pretty much invalidate it once we've got one sample. I think we're working on sort of being able to specify how many samples you want to collect, but for now it's just one. So once that's been collected, you have to reset it if you want to get another one, right? So let's reset it, and then what I'm going to do is I'm going to stop and go back to work. So here, if you look over here, let me zoom in, right? It's asking you if you want to continue listening. So I guess we do, really. We want to be notified when this happens, right? So we can continue. Zoom back out. And now I'm going to go back to work. I'm going to do some feature development, right? Let's make this more polite. Hello, Mr. or Mrs. Yeah, you're using the must be verbose, right? I'm like, maybe I've spent a week like just changing, just working on features, moving on with my life, right? Because I can't reproduce this thing, and apparently it's not being hit in production anymore. And now, right, this dreaded bug happens again. But look at this. And we get notified about this bug happening in our natural workflow, and we can say, I want to continue. And look at this. We've detected that the version of the source that you're on is not the version of the source that's in production right now. And we will automatically stash your changes and match what's in production. So pop back out here. You see, like, my changes are gone, right? And if I go here, I can see what was captured. Another really neat thing that you can do is, like, let's put this here, trackpad. There we go. Conditional breakpoints actually work. So if you want, you could say like request.getSession. Maybe you have something somewhere in your logs which session it's related to. You can filter out all the requests coming in, even if you don't have any code that does that, and only capture the snapshots related to one specific session ID or something like that.
And there's actually also permission control or access and management control. So you can actually, if you want to, restrict who has the ability to do this, right? Because obviously, if you're peeking into state like this, there's a lot of possibly sensitive information, right? So you can limit access to who can actually do production debugs.
That was a requirement for us to use this in production. Okay.
Actually, the logging, my whole logging tirade of the problems. Is there something related to this we can that helps out, right?
Yeah. So let me so I'm going to stop listening, and now it tells me, hey, you're done. I can unstash your changes, and we're back to where we were before. And now let's go to logging. This is kind of a similar use case, really, right?
Yeah.
What do you think of like a good scenario for this?
Over just putting straight up statements. Maybe you just want to collect stats, possibly. Yeah. I mean, maybe if you want to do some ad hoc statistics collection.
Also, if you're feeding your logs into BigQuery, right?
Yeah.
So Google has another product called dynamic logging, which is basically like you should have put a logging statement in your app, but you forgot. It's basically you found this issue. Maybe it's a bug. Maybe it's some stat that you need to collect, right? But you don't have the logging statement you need. Well, you can actually create a dynamic logging statement. First, let me bring you over to our logs viewer, right? So this is our actual app. I've got the old logs in there. But, so if you go over here, this is the latest run, right? And I think that log points are already there, but so it's debug, right?
It's under the beta.
There you go. So we've got this beta command, which lets you specify a file in line, right? And actually add a logging statement into your running app. And when you do that, I mean, I'll do that, but it looks like it's already.
Maybe change the.
So it's done, right? You can actually use, I think it's OGNL probably, OGNL paths to get to data of state in your running app. And when you do that and you hit your endpoint, go back to the logs viewer. Yeah, there you go. It actually updates all of your instances to print out this logging statement, right?
And it's showing multiple times because we've set this log point a couple of times, so that's what
I forgot to remove it the last time I did.
And a cool feature that we'll add to the IDE, doesn't exist yet, would be the ability to overlay dynamic logs for a given session, log points, onto your source code, right? So right now, if you look in your IDE, it doesn't, you can't see where they are, but we do have enough information to actually do that correlation.
Yeah, that's what I was going to say. So this is sort of, these are features that we've had internally for a long time, really our ambition is to integrate that into your workflow and your IDE. So everything we're doing with trace, so we have a tracing suite with profiling, with logging. We want to that should be with your code, right? Okay, I think that's it for the demo.
Cool, thanks, Patrick. Let me just flip back over here.
Oh wait, I did forget one thing, but you don't. I'll just mention it. I'll just say it.
All right.
If you do ever play with this, if you create a Kubernetes cluster and scale it up to 10 nodes or something like that, please don't forget to delete it when you're done, because you're paying for those cores, and that can kind of add up.
Well, especially if you expose an external IP,
Yeah.
so with no auth, right? So yeah,
Maybe also bad.
yeah. So what did we just see? Patrick showed us a lot of cool stuff, right? So just to summarize, Kubernetes is pretty powerful, and container engines, it's pretty quick. So it wasn't too hard to, looking back at that picture of that data center, to say hey, I just want to spin up a cluster of multiple VMs, really, and then I want to take a package of software and go run it. You go distribute it, and then I'm going to put that behind a single IP address.
I think Ray was saying you can do 2,000 nodes right now.
Yeah. So it's a pretty powerful system when you think of how easy that was to really do. Right. And yeah, going back to, that was a standard Spring Boot application, right? And there was nothing special about it. There's no special libraries. It just worked, and it was working on Google Container Engine.
And cloud logging worked as well.
Yeah, exactly. But you could have actually been running that. That was really running on Kubernetes. It could have been running anywhere, honestly. You could have been running on AWS. You could be running it on premise. There was nothing special about that needing to run on Google Container Engine. And with just a bit of configuration, which Patrick showed you with the debugger agent and everything, you could debug, right? You were able to debug without stopping threads. And the interesting thing about this is you can actually use this on this is not even specific to Google. Clearly you have to go to it's Google service, that's the cloud debugger service, but the workload can run anywhere. You could have even done that locally, right? If you wanted to.
Yeah.
So
maybe we're beating a dead horse for that one.
Yeah, we are. Yeah, we'll stop with that. And yeah, that clearly was integrated straight into the IDE, and we're actually doing, and we're actually building this into Eclipse as well. We recently released the cloud tools for Eclipse, for which has App Engine support, and we're working to bring in the cloud debugger.
That is one thing that I did forget. I was going to show you that we have a GitHub site for the IntelliJ plugin. If you want to install it, we're in the JetBrains repository. Right, and we offer more than just Cloud Debugger. It's going to be sort of everything that we have to offer. For now, it's Cloud Source repository integration, so you can check out and import sources into Google Cloud Source Repo. We provide repos with your projects for free. And App Engine deployment, right? App Engine project generation. We're actually in the process of transitioning the JetBrains provided App Engine tooling over into our plugin. Some of you guys might have installed it and noticed already. And yeah, now we're doing the same for Eclipse.
Just one thing I want to mention here about Google Cloud Platform infrastructure. We're adding more basically points of presence, right? Into I think one's coming in Finland, one's coming in Frankfurt. There's some new ones that got added in Tokyo and Singapore. So what this means for you, honestly, is if you're running, basically this is just a faster way to get on Google's network if you're running workloads there. So this is good stuff. And just closing here, where to find us. Here's the Google group. If you have any questions, just Slack channel. Here's all our GitHub repos. Everything's open source, so please take a look. And we'll leave that up here if anyone wants to take a picture or something. And
I was just going to say, one of the big reasons we came is because we really want to get to know the users. We've been kind of working internally for a long time, but we haven't spent as much time as we should talking to our external users. So if you're interested, if you want to contribute, we'd love to hear from you. Our GitHub repos, our Slack channel, our Google groups are all good forums or just email me directly.
Cool. Well, thanks a lot. Open for questions. Sure. Okay, so the question was, what is the performance hit on debugging, especially if you have high traffic? Patrick, you want to field this?
Negligible is what I'm told. and I believe it because we use it internally for high traffic websites. Yeah, it's pretty mature. It's been used for a considerable amount of time now internally. What it does is, like you saw, for instance, that you have conditional breakpoints, which means you can do some code execution, right? The agent is pretty smart and uses heuristics and things to make sure that anything that you do execute doesn't take too long. If it does, it'll actually not work. It'll basically come back to you and say that it's not going to use this snapshot.
Any other questions? Looking, it's hard to see all of you here in the theater. Sure, yeah. The question was, can you do method breakpoints?
No, not yet. Not yet. I don't think. I could be wrong, but the last I checked, it was impossible. So you can't do exception breakpoints either. And you know, worth mentioning, it also works for Python, and is it just Python and Java?
No, I think it also works for Go.
Yeah, that's right, for Go as well. So you can run Go.
And I believe it also works for Node.
Oh, yeah.
Node.js, yeah.
Sure. Cool. So just put up our communication details if you want to get in touch with us. And that's it. Thanks, everybody.
Thanks for your time.